Bismillahirrahmanirrahim. Student, Assalamu alaikum. Welcome to my channel Ahmad Skills Academy. Today we will discuss about the different conditions which are required for the equilibrium state to be reached. Without these conditions, the equilibrium may be disturbed. If you are going to change the concentration of reactants or products or temperature, pressure and volume, so the concentration of the reactants or the concentration of the products in forward reaction and the backward reaction, it may be disturbed, and the equilibrium value, the value of Kc will also be disturbed. Now remember that if you start the reaction from reactant side, like in this reaction, if you are going to decompose hydrogen fluoride into hydrogen and fluorine, or you are going to combine hydrogen and fluorine to form hydrogen fluoride, in both the direction the reaction can occur. If you place hydrogen fluoride in a container, if you place hydrogen and fluorine in a container, or if you place hydrogen fluoride, hydrogen and fluorine in same container, even then the reaction will occur at the same rate in forward direction and the backward direction once the equilibrium condition is reached. Now the conditions for equilibrium is there must be no change in concentration of reactants and products. Once the equilibrium is reached, once you are going to obtain the value of Kc for certain reaction, so you have to make the reactants and products, that is once taken in the container cannot be changed. Then एक बार अगर आपने reactants और products को ले लिया तो बार बार उसकी concentration को आप change नहीं करेंगे, otherwise equilibrium concentration फिर change हो जाएगी, equilibrium की value आपकी change हो जाएगी. Temperature must remain constant, there must be no change in temperature, and similarly no change in pressure and volume. If temperature, pressure or volume is changed, so again the equilibrium condition will be disturbed, and either the reaction will move in forward direction, either the reaction will move in backward direction, in order to minimize the effect of the change which is brought about in the temperature, which is brought about in the pressure, which is brought about in the volume. Now these are certain conditions which may be followed during the equilibrium state, and in higher classes we will read that the change in concentration, change in temperature, change in pressure and change in volume, these are the effects of these changes on equilibrium state, which is discussed in Le Chatelier's principle. So that is a complete question. Le Chatelier's principle, we will discuss it later on for the first year syllabus. Now till this time this is the metric class syllabus, so that is why I am not discussing these Le Chatelier's principle now. Now the second portion for this reaction, how to write equilibrium constant expression. So students याद रख ले कि जब भी आप equilibrium constant expression को लिखते हैं, उसमें Kc is always equal to the molar concentration of products raised to their powers divided by the molar concentration of reactants raised to their powers. कोई भी रिएक्शन दिया जाए तो आप उसके प्रोडक्ट वाली साइड जो आपके राइट पे हो उसको आप ऊपर लेके जाएंगे, जो आपके लेफ्ट पे हो उसको आप नीचे लेके आएंगे. फॉर एग्जांपल अगर हम कार्बन मोनोक्साइड हाइड्रोजन का रिएक्शन देख ले, विच विल फॉर्म मीथेन एंड वाटर. इसके लिए अगर आपसे पूछा जाए, ये शॉर्ट क्वेश्चन में पूछते हैं अक्सर बोर्ड एग्जाम्स में, कि राइट डाउन द Kc वैल्यू फॉर दिस रिएक्शन. सो Kc वैल्यू इज इक्वल टू द मोलर कंसंट्रेशन ऑफ मीथेन multiplied by the molar concentration of water divided by the molar concentration of carbon monoxide and the molar concentration of hydrogen gas, which will be raised to power 3. This is the coefficient of hydrogen. Now Kc मैंने आपको पहले बता दिया कि it is always equal to products divided by the reactants. तो हम जब भी लिखेंगे हम products को ऊपर लेके जाएंगे न्यूमरेटर में और reactants वाली साइड को नीचे लेके जाएंगे डिनोमिनेटर में. ठीक है. Similarly अगर आप इस रिएक्शन को लिखना चाहें तो Kc value for this reaction will be the molar concentration of hydrogen multiplied by the molar concentration of fluorine and divided by the molar concentration of hydrogen fluoride raised to power 2. For this reaction Kc will be equal to molar concentration of ammonia raised to power 2 multiplied by divided by molar concentration of nitrogen multiplied by the molar concentration of hydrogen raised to power 3. किसी टाइम पेपर में ये भी पूछा जाता है कि राइट डाउन द रिएक्शन फ्रॉम दिस एक्सप्रेशन. तो अगेन Kc वैल्यू अगर आपको प्रोवाइडेड है तो मैंने आपको पहले बता दिया कि थंब रूल इज प्रोडक्ट्स डिवाइडेड बाय रिएक्टेंट्स. तो जो न्यूमरेटर में है, जो ऊपर है उसको आप प्रोडक्ट वाली साइड पे ले आए, जो नीचे है उसको आप रिएक्टेंट वाली साइड पे ले आए. दैट्स ऑल अबाउट द conditions of equilibrium and how to write down the expression equilibrium constant expression from a reaction, or how to write down a reaction from equilibrium constant expression. Again one thing कि जहाँ पे हम square bracket डालेंगे, the square bracket always means molar concentration. These are the active masses, and these active masses are nothing. This is equal to the mole per decimeter cube of each reactant in each product which are involved in the reaction. That's all about the conditions and equilibrium constant expression. अब तक के लिए इतना ही. लास्ट टॉपिक इस मैट्रिक की केमिस्ट्री में हम केसी की जो इम्पोर्टेंस है, व्हाट आर द इम्पोर्टेंस ऑफ केसी, वो डिस्कस करेंगे. तब तक इजाज़त दीजिए. अल्लाह हाफिज़.